So, hello everyone. I'm Eric Randall, and welcome to CBRS Part 2. In the last webinar, we discussed the basics of CBRS, what it is, how it is used, and who can use it. Today, we are going to go a little bit more in depth and discuss the actual pieces of CBRS. So we will look at the user equipment, the eNode Bs, network managers, and the core. Today's discussion will hopefully give you the knowledge needed to make an informed decision on your CBRS rollout. So let's go ahead and get started with this. So CBRS is Citizens Broadband Radio Services, and there are four major components of the CBRS. There's the user equipment, which short for UE. That's the equipment that's at the customer location. There are the eNode Bs. That's the equipment on the tower, the network managers, and the core, and they can reside anywhere from your head end to a cloud. So we'll talk about that briefly later on also. So there are, like I said, a few exceptions to this, and that's where your network managers and the core could lie somewhere else. So before we get started into the deeper dive and discuss these, I want to just review it real quick, like a 30-second review. So CBRS is Citizen Broadband Radio Services. It is known as Band 48. It has up to 150 megahertz of spectrum that could be used. Every device on CBRS is called a CBSD and must connect to a Spectrum Access System, or SAS. The SAS is a database of all the information used in CBRS, all of the eNode Bs, the UEs, their locations, transmit power, and more. So I just wanted to get that out there because that's kind of the basis of how this entire part 2 goes. So let's go ahead and start looking at our UEs. So user equipment is the first device seen by the customer. Whether it is mounted on their house or sitting in their kitchen window, it is there. It's the customer's location. The UE has several different aspects to look at to choose which is best for your system. Here are some points to consider when looking at your UE. We will start by discussing the LTE UE categories, then indoor versus outdoor, carrier aggregation on the user equipment, the antenna arrays, and the connectivity to the SAS. Lastly, to put it all in perspective, we'll put up a couple of different vendors, and we could even give you a link in the future, or if you email us, we can give you the link to all of the FCC approved CBRS UEs. All right, so to start, we have LTE UE categories. So LTE categories for the user equipment is a set of standards defined by the 3GPP. For the most part, as the categories advance, category 4, category 6, so on, so does the throughput. So if you look at the chart over there, you'll see category 0, we have a max download of 1, max upload of 1. Category 6, we have download 300, upload 50. And as you advance, you see category 12, 600 down, 100 up. With CBRS and fixed wireless, we are currently seeing predominantly category 6 and category 12. That's the ones we most often see now. So, of course, as your categories go up, the more expensive they're probably going to cost. So your LTE categories will define the performance specifications. It allows the communication with your eNode Bs, and it will help define your antenna arrays. The one thing that threw me off when I first started with CBRS and the categories, I started in about 2 years ago, and they were talking about Cat 6, Cat 6, Cat 6. It threw me off because Cat 6 is Ethernet cable. So don't make that same mistake I did. Category 6 UE is not the same as Category 6 cable. All right, indoor versus outdoor. This is, a pretty big consideration, whether you have a quick and easy install or send a truck roll out there to mount a pole and put up an antenna. You have your choice of an outdoor UE. It provides much larger gain on your antenna and allows for farther distances from your eNode B. That's, a consideration to take. Whereas your indoor UE, it could be a self-install kit that you hand to a customer and say, put in your window facing, the north side. And your customer could hook it up and hopefully it'll work straight out. There are two different considerations there. You have easy installation, weatherproofing, and antenna gain to think about whether you want to go with an indoor or an outdoor CPE or UE. So carrier aggregation. It's another major factor in determining not only your UE, but also your eNode B. Carrier aggregation is defined in the 3GPP standards as LTE advanced. It combines multiple carriers into one carrier to increase the bandwidth. Your carriers can be contiguous or non-contiguous, depending on what you have available. As mentioned earlier, the different categories, anything over category 6 is considered LTE-A, which is LTE advanced. So next is our antenna arrays. Another major factor in considering your UE would be the antenna configuration. The antenna configurations make a large determination on how well the link runs or how much throughput you can get from your link. When we say 2x2 antenna, the first 2 stands for your transmit and the last 2 stands for your receive. So if we have a 2x4, that would be 2 transmitting and 4 receiving. Anything over 1x1 is known as MIMO, or multiple in, multiple out. Having MIMO increases the throughput by sending and receiving data on multiple antennas instead of just one. MIMO also increases signal by reducing multipath. Some UEs will be 2x2, 2x4, or 4x4. You will have others that are 8x8 at this time, but for the most part, this is what we're looking at are the 2x2s, 2x4s, and 4x4s. Connectivity to the SAS is extremely important. In fact, it has to be done. That's one of the requirements for CBRS. So the SAS assigns frequencies and gives permissions for the UEs and the eNode Bs to communicate. There are different methods of communicating with the SAS. Some UEs have a direct approach where all of the information needed for the SAS is directly on the UE itself. CIRCOM is a UE manufacturer that utilizes this. All of their information is right there on their GUI. You put that in, and that's how it communicates with the SAS. Other vendors are looking at doing this, and I know there are others that do it, but CIRCOM is one of the ones that currently do it. Another way the UEs communicate with the SAS is via a network manager. This allows the WISP more control over all of the UEs, and the network manager can work on a whole network basis instead of per each UE. So how that would work is the network manager controls each one of the UEs. We would go into the network manager, enter in all of our SAS information, and then that would communicate back to the SAS. So BiCells and BEC are 2 UE manufacturers that deploy network managers for SAS communications. All right, so some UE vendors, CPE vendors. There are a ton out there. So up on the screen, you have several options there to look at. We distribute for some of them, but not all of them. So here's a quick list. You have BiCells, CIRCOM, Telrad, Cradlepoint, GreenPacket, and Redline. The full list, as I mentioned at the beginning, is down there at the bottom, cbrsalliance.org/certification. That has the full list of every CBSD that is registered to be Part 96. All right, I'll leave that up there for a second for everybody. So basically, looking at every vendor, looking at the different components within those vendors, the pricing, the antenna configuration, the category, will hopefully give you a good feel for what you want to put out in your network. All right, we'll go ahead and move on. So now we'll look at the eNode Bs. The eNode B is the base station. It will be, for the most part, at your tower. We will look at carrier aggregation, what it means, how it is used in the eNode B. We will go into detail on MU-MIMO, the scheduler, sector antennas, and last same thing, connectivity to the SAS. So let's go ahead and start off with our carrier aggregation and the eNode B. So as mentioned with the UE section, carrier aggregation is combining multiple carriers into one. I have seen so far up to 3 carrier aggregation, that's in CBRS guys, LTE CBRS, 3 carrier aggregation so far. That will get you 60 megahertz per sector, allowing close to 600 megabits per second aggregate for a 2x2 solution. Carrier aggregation is a way of taking advantage of available spectrum to provide more throughput. CBRS has 80 megahertz of general access, and if you win some PALs, you could have plenty of spectrum to reuse. Aggregating the spectrum will provide the most bang for your buck. You know, if you're paying for all of that, hopefully you can put it all together and provide it to all your customers. So MU-MIMO, I like MU-MIMO. MU-MIMO is great. It's one of the more impressive technologies that I've seen here in the last few years. So MU-MIMO stands for multi-user MIMO, meaning multiple users can connect to the base station at the same time instead of depending on the scheduler. We'll discuss the scheduler next. So how does this work? There are multiple beams that form directly to give each user equipment a single beam instead of sharing a sector with multiple UEs. Beam forming helps reduce interference and increases transmit and receive power to and from the UE. The beams, instead of being a sector antenna of your 90 and 120 degrees, it becomes narrow. It drops down to anywhere from 5 degrees to 10, 12 degrees. So it's significantly smaller. So how it basically works is your antenna will have a coverage on it of 140 degree coverage. It's not radiating for that entire 140 degrees. It's just there. And then when a UE sends it off, the sector will see that it's there and it'll form a tight beam. And that's how the beam forming forms for MU-MIMO. So another aspect of the eNode B would be the scheduler. We have the antennas and configuration, but how does the eNode B communicate with so many UEs? This is done through scheduling and is done at the eNode B. The eNode B has several different scheduling algorithms. On the screen, you can see that there's fairness, round robin, and on demand. So they're just a few. There are others out there, and you can set that, and your eNode B will decide exactly what UEs will communicate and when, and how quickly it's done. So in the last slide, we were talking about beam forming, and it comes down to a 10-degree beam. I had a question about 2 weeks ago. What happens if I have, 5, 6, 10 houses in that 10-degree beam of where that beam forming is? In that case, the beam forming is not going to be able to pick out one particular house. That beam is going to have to start going through the scheduling to communicate with those several houses within that smaller degree. So sector antennas. To make a 360-degree coverage, you would think that 4 90-degree sectors would be perfect, but in reality, the 4 90s will cause interference. So best practice would actually be to use 4 65-degree antennas to cover the full 360 degrees. This will give a little overlap, but not nearly as much. So take a look at these pictures on the left. The top picture shows, what we would think, 4 90s would make a piece of the pie. Give me, a quarter of that pie. There's no overlapping unless that pie, bleeds over after you take the piece off. The middle piece shows the actual radiating patterns of 4 90-degree. So you can see the colors, how much, 190 degree will not only interfere with the channels next to it, but also the channel behind it. So that's actually really inefficient. You don't want to do that because of the interference. That's the middle with 490s. Again, the recommended is going to be that bottom one there, the 365s. You have not much more null. If you look at the white areas, that's your null areas where you don't have coverage, or a lot less coverage. But you have a lot less, and you don't have the interference that you do from your 490s. And with the nulls, with good engineering and designing, you could avoid that. You could find your customer locations and make sure that your customers are not on those nulls by readjusting your sectors as needed. So just like the UE, the eNodeB must connect back to the SAS. The only way I've seen this done so far is through network managers. So you have your Ericsson, your BioCells, your Cambium. They all have their own network managers. They all perform their own way to each of the SASs. And we'll discuss more of network managers here shortly. So the last two sections here, your network managers and the core. So network managers control all the physical devices on a network. Some CBSDs will be proprietary to their network manager and would require an additional network manager compared to your eNodeB. In the example of Ericsson eNodeBs and BEC UEs. So BEC has one network manager, Ericsson has another. So the two of them, you would have two network managers. So this, is a typical WISP type rollout. So that's just something to be aware of. In the picture, we can see the different network managers. You have CN Maestro there, or Cambium there, and then at the bottom you'll see Cloud Core. The network managers are an extremely important aspect of CBRS. They perform the communication between the CBSDs and the SAS. And in CBRS, that communication, it is a must. As discussed before, if an ESC sees something, it has to be able to move every one of those devices off of that frequency. So that's where the communication is a must, and the network managers come into play. Network managers and cores come in local, hosted, and cloud options. The local means you will have the servers with the network manager and the core residing locally, right there on your network, probably in your head end. Hosted means you will be leasing your network manager and core from another entity. And cloud means you will be utilizing the CBSDs, whether it's your eNodeB or UE manufacturer's network manager and core, and paying them for this service. So for more information on network managers, Camille, one of my colleagues, he did a great webinar, I think about a month ago. So you could look back on Winncom's old videos and webinars, and you can find his video on network managers. So that's actually a really good video too. So the core. The core is a misused word prior to LTE. The core in LTE is considered evolved packet core. It's actually one function of the CBRS network. It's one function of what you do. Whereas the core before was basically everything within your head end. That was your core. So kind of like the UEs in the category Cat6, the core is not the same core that you remember. Cat6 is not the same Cat6 you remembered. So the core is the evolved packet core. It is the core of the network. It's the core of the LTE system. A lot goes into the EPC. This slide shows all of the components that are within the EPC. We won't go into detail about each one of the components, but in short, the core is the brain. It is in charge of keeping the user database, enforcing policies, allocating IP addresses, managing mobility and tracking, and giving gateway to the public data networks. So your core is pretty much controlling all of your communication from your SIM out. So that is the actual core. So that's basically everything with part 2 of CBRS. So how can Winncom help? Winncom's ultimate goal is to help our customers succeed. In addition to our industry-leading portfolio, large stocked warehouse, and quick response times, Winncom also offers pre- and post-sales technical support and engineering advice. You have me up here, and in 2 weeks, you'll have Dave, 2 or 3 weeks, you'll have Dave doing a TV white space. We're the engineers that are putting bombs together, that are designing things. We want to help you guys. So if there's anyone out there that needs assistance on this stuff, we'll help with that. So when you're looking for detailed product specs and instructions on how to use any of the products, or even just engineering advice and system design, let us know, man. We're always available to get on a call with our customers. So just to go into some of our engineering services, I'm going to start with the pre-configuration and staging, because I think that's like the best thing we can talk about. Say you have a customer out there, or say you're deploying something and you don't want to spend too much time climbing a tower. You just want to get it up there and get it done. We can pre-configure it for you. We can log into it here in our warehouse. We can add in all of the IP information. We could stage it to where all you got to do is hang it, to where it's already connected to the other end. So I think that is an underutilized service that we have here that people should think about. So outside of the pre-configuration and staging, we also do design work of point-to-points, point-to-multipoints, Wi-Fi systems, DAS, and LTE projects. We use the best tools out there for LTE propagation studies. We use ATOL. For Wi-Fi, we use AirMagnet. For point-to-point designs, we're using path loss. So we utilize all the most advanced tools out there to give to our customers. We also provide bill of materials, whether it's budgetary to get you started, a quick budgetary quote, or whether you need the finalized quote with all the nuts and bolts, all the grounding. We can go into great detail and tell you exactly what you need to include your tower, your cabinets, and your power. Anything you need there at the site, we can help you out with. And then the last thing, we can provide consultation and training services. We have, well, almost every one of our engineers are certified trainers in different products, in different technologies. So we can either give you certification trainings for different vendors like BioCells and Cambium, or we could put together a specialized training just for you, whether you want to learn more about LTE or more about licensed point-to-points. We can put together specialized trainings for you. So our initiatives from Winncom is to accommodate connectivity needs. So anything you need at all out on site, we can take care of it. So as mentioned before, Dave Thackerton will be doing a TV whitespace reality check on September 10th. That is our next one at 2 p.m. So please join him. Everybody, thank you for joining me today. All of my information's up there right now. And then the next slide, here's our sales map. So if you're looking for your local salesperson, all of that's up there. So we'll go ahead and leave this up for a minute, and that's going to be the end of the webinar. Again, thank you everybody for joining us today.